Hey guys, welcome back to STR8CHEM. In this video, we're going to look at on how to write a set of quantum numbers of electrons in an orbitals. Let's start with problem number 1. Give a possible set of quantum numbers of an electron in 3s. So we only need to give one possible set of quantum numbers of one electron that is located in 3s orbitals. Okay, so remember when you see this term here, that one refers to orbital, or sometimes they can use the word subshell. And in here you can have electrons inside. Electrons are located in here. Remember that. So when the electrons are inside this orbital, those electrons will have a set of quantum numbers. A typical set of quantum numbers we have looked at in the Puzzle video. Okay, a set of quantum numbers. I'll do that again. Okay, a set of quantum number consists of n, principal quantum number, L, azimuthal quantum number or angular momentum quantum number, magnetic quantum number, spin quantum number. And underneath here, you can have the numbers. Okay, so that will be the identity or the location, if you will, for a lack of better term, for the electrons inside the subshells or orbital. This time in this question, it wants you to find out the only one possible sets. Okay, only one possible sets. So do remember that in 3s, you can have one electron and add two electrons. So inside this 3s subshells, you can have electron that is going spin over here and spin down there. So you have two electrons inside s orbitals or in the subshells. So we're just going to give one of them. So first of all, we can see that's the n value. Okay, the n value is obvious, is right over here. So that one will be the value of n. And then s will give you the idea of value of L. Okay, so right now in this case, the set of quantum number n, L, m, s, you can have it 3. Now you have 3. And s, okay, s over here, remember, L, you can have 0, 1, 2, 3, and so on. And you have S, P, D, F. So when you have S, your L will be 0 value. And do remember that the M over here, the value of M depends on L. So that is super important again. So the value of M depends on the value of L. So when you have L equals to, when you have L equals to 0, then your M will equals to 0. So the value of M for that will be 0, and you can pick either you want to write for positive half or negative half, because you only need to give one possible set. So let's say I'm going to write for negative half. So this is the answer. Okay, so you've got your answer right here. And when you write that, because the question wants you to write only one possible set, you have 1 mark. Let's have a look at another one, shall we? Okay, now the question wants you to give two sets of possible quantum number. We're going to start with the same strategy. We're going to write 3D, okay? And we do know that the number 3 over here refers to the value of n, and D over here refers to the value of L. And we do know that L can have 0, 1, 2, 3, and so on. But for your level, we're only going to stop until 3. So L equals to 0 is S shape, P, D shape, and F shapes. And to write two sets of possible quantum number, we're going to start with N, L, M, S. Nasi lemak memang sedap. So you have the first set over here. 1, 2, 3, 4. And then you have the second set. Okay, 1, 2, 3, 4. We do know that the value of 3, n is 3. So you're going to put 3 and 3. And the value of L is D. D is 2 here, so you have 2 and 2. And remember, the value of M when L equals to 2, M you can have -2, -1, 0, +1, or +2. You have 5 orientations. So you can pick either one. So if you want to pick 0 here, you can do that, or +1 or -1. That should be okay, because the question wants you to give only two sets of possible quantum numbers in 3D. So I can pick maybe I want to put -2 here, or I can put 0 there. Should be fine. So for the spin, I can pick +½ or over here I can put -½. That should be fine as well. So by writing that, you should be able to get 2 marks. So those are the two sets of possible quantum numbers for 3D. You have 1 mark and 1 mark. Next, we're going to look at this one. Give the possible sets of quantum numbers. We need to give all possible sets of quantum numbers for the electrons in the highest energy subshell. Okay, remember the word subshell in nitrogen atom with proton number Z equals to 7. In this case, we're going to write first, we're going to change that into the SPDF notation. Okay, that is very important. So the SPDF would be 1s2, 2s2, that is 4. 1, 2, 3, 4, and then you have 7. 3 more electrons, so you're going to put 2p3. Okay, so 1, 2, 3, 4, 5, 6, 7. So the highest energy, the electrons in the highest energy subshell. So the highest energy subshell is this. Okay, so that is the highest energy subshell. Okay, so that is the so this one is the lowest energy subshell. That one is the intermediate subshell. This is 1s subshell, 2s subshell, 2p subshell. Okay, you need to remember that. So in here you have 3 electrons. So you can give 3 possible sets quantum numbers because you only need to have 3. So to do that, remember N, L, and S. So you can have, okay, that one is 2. And then the L value over here is P. P is equals to 1. Yes, okay, so you have 1. So the M value will depends on P. So when L equals to 1, M equals to -1, 0, plus 1. So I can pick either one of them. Maybe I just want to pick -1. So again, -1, and I can have plus half, and L and S, 2, 1, 0, um, plus half, and then N, L, M, S, 2, 1, positive 1, plus half. So these are the possible quantum numbers that we can have for this question. Okay, so you're going to write it that way because you have 3 electrons right here. Okay, that's why you're going to have 3. And you have 1 mark, 1 mark, and another 1 mark. Okay,